The farthest object humanity has ever launched is currently drifting through interstellar space at 38,000 miles per hour. That speed is staggering by human standards, yet it remains mathematically insignificant. At this pace, reaching our nearest neighboring star would take 73,000 years. Increasing that speed introduces a different kind of lethality. At just 10% the speed of light, a single space dust grain, smaller than a human hair, strikes with the explosive force of a bomb. Distance, energy, time, and biology form an interconnected system of barriers. In the vacuum of deep space, solving for one variable almost always makes the others worse. To visualize the math of these distances, imagine shrinking our entire solar system until the sun is the size of a standard basketball. On this scale, Earth is a grain of sand sitting 85 feet away. Neptune, the outermost planet, is a small pea half a mile down the street. Place that basketball on a sidewalk in the middle of New York City. The nearest neighboring star, Proxima Centauri, would be located 4,000 miles away on a sidewalk in Honolulu, Hawaii. On November 18, 2026, Voyager 1 will reach a distance of exactly 1 light day from Earth. It has taken the probe nearly 50 years of continuous flight to cross that single unit of measure. However, Proxima Centauri sits over 1,500 light days away. After half a century, Voyager has covered less than 1/1500th of the distance to our closest neighbor. This scale makes traditional travel impossible. To reach the stars, we are forced to choose between two extremes. We either accept thousands of years of transit time, or we attempt to move at speeds that challenge the laws of physics. The slow path requires generation ships, massive, self-sustaining habitats designed to support thousands of years of human life in the void between stars. But time is biologically destructive. Without the protection of a planetary magnetosphere, galactic cosmic rays bombard the crew, causing permanent damage to brain tissue and DNA mutations that accumulate across generations. History shows that sealed ecological systems are incredibly difficult to maintain. Even on Earth, projects like Biosphere 2 suffered catastrophic atmospheric and ecological collapses within just a few years. Mechanical entropy presents an equal threat. Over centuries, moving parts seize, structural seals degrade, and the ship's plutonium power sources slowly fade into cold, dead metal. Specialized knowledge is also fragile. When the Roman Empire collapsed, specific engineering skills to maintain aqueducts and manufacture concrete were lost for centuries. In the isolation of a starship, a single generation that fails to master the complexities of a fusion reactor would face total life support failure. Because of these biological and mechanical realities, the long journey is less a path to a new world and more an inescapable trap of gradual decay. The alternative is the fast path, traveling at relativistic speeds to shorten the journey. The energy costs are astronomical. Accelerating a small truck-sized ship to just 10% the speed of light requires the energy of 1,000 megaton nuclear explosion. This chart shows the energy barrier created by relativity. As a ship's velocity approaches the speed of light on the x-axis, its effective mass increases, causing the energy required for further acceleration to spike toward infinity. At these speeds, the vacuum of space is no longer empty. A microscopic dust grain strikes with the impact of 600,000 bullets. Even drifting hydrogen atoms become a hazard. At relativistic speeds, they are transformed into a forward-directed radiation storm that would deliver a lethal dose to a crew in a matter of days. Deceleration adds a final layer of difficulty. To stop at the destination, a ship must carry twice the fuel, effectively doubling the mass and the energy required for the entire journey. Physics offers no shortcuts. Attempting to move fast turns the foundational laws of mass, energy, and relativity into absolute physical barriers. The math indicates that interstellar travel is restricted by the permanent architecture of the universe. Our isolation is a built-in feature of reality. Humanity is physically anchored to the solar system, but our reach is measured by what we can observe and understand. We remain a species of limited movement but unlimited vision. We represent ourselves through the artifacts we send into the void, like the golden record carried by Voyager. 40,000 years from now, Voyager will drift past a distant star. It will be silent and dead, but it carries our music and our record of existence into the dark. We may never walk among the stars, but we have already sent our history to drift among them.